Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Luis Fernando Gazcon.
Thanks, William. Hello again to all our subscribers and followers. We welcome you to this new Tech presenting how to prepare a maintenance checklist for your washing equipment. We will be offering some tips to take advantage of your next plant shutdown this summer. But first, why is a regular maintenance important for your washing equipment? Well, regular maintenance is essential for several key reasons, particularly in industrial, commercial, and manufacturing settings. The first one is it ensures optimal performance. Maintenance cleaning efficiency and effectiveness of your equipment, preventing buildup of residues that can affect process performance. It extends equipment lifespan, reduces wear and tear on components, delaying the need for costly replacements. Third, it minimizes downtime, prevents unexpected breakdowns that can halt operations, allowing for rescheduling repairs instead of emergency fixes. Fourth, reduces operating costs. A good maintenance in your equipment improves energy and liquid flow efficiency, preventing overuse of detergents and chemicals. Five, it enhances safety, reduces the risk of accidents caused by malfunctioning parts or leaks, and keeps electrical and mechanical systems functioning properly. Six, well, it protects product quality, ensures that parts and equipment are properly cleaned, avoiding contamination. This is a critical point in sectors like food processing, pharmaceuticals, aerospace, medical, and automotive. Seven, supports compliance with regulations, helps meet industry hygiene and safety standards, avoids fines or shutdowns due to inspection failures. And finally, it improves environmental sustainability. It helps you limit waste and chemical runoff by maintaining correct systems calibration, promoting responsible use of the resources. Key components of basic checklist for washing equipment maintenance. Much of this information is typically provided in detail within your equipment manual, including manufacturer recommendations that should be carefully followed. We strongly encourage you to thoroughly review your equipment manual, especially the maintenance section, as it includes essential information such as spare parts lists and tasks that must be addressed in a timely manner. Each piece of equipment has its own design and critical points, but most manuals will include, though not limited to, the following areas: mechanical parts inspection, electrical system check, inspect fluid systems and piping, cleaning and decontamination, safety mechanisms, lubrication points, and calibration of sensors and timers. It is important to note that fluid systems and piping checks, as well as cleaning and decontamination, are key areas that are often overlooked. These tasks are closely tied to the chemical aspect of the process, which is why we will be focusing primarily in these two components. Fluid systems and piping inspection. The first step in this inspection is to drain all tanks, including both the wash tank and the rinse tank. If your system includes both, of course. The goal is to fully expose the internal surfaces of components of the tanks, such as pipes, resistors, heaters, thermostats, floats, or level switches. This exposure allows you to thoroughly inspect each part to ensure it is operational and free of residue. Once drained, all liquid residues must be disposed of in accordance with local laws and environmental regulations. To reduce the volume of waste, one effective method is to use an evaporator, which removes water and other volatile components from the mixture. This process minimizes the amount of residue requiring disposal and helps you reduce your overall disposal costs. As you are likely aware, industrial residues often contain heavy greases, oils, and solid particles. These materials tend to settle at the bottom of the tank over time, forming sludge or more mud, a layer of mud that can impair equipment performance and cleanliness. The step 2, tank and wash chamber inspection. Once the tanks are emptied, proceed with inspecting the interior of the tank and wash chambers. Focus on identifying any sign of damage or performance issues, such as wear or tear on belts, chains, seals, filters, tubes, or hoses, leaks in water, detergent, or compressed air lines, motor performance and unusual bearing noise, clogged or degraded filters, strains, and drains. It is common to find sludge buildup, often visible at the bottom of the tanks or inside piping, as shown in the image in the top right corner of your screen. Sludge is typically vacuumed out or manually scrubbed and flushed from the tank. To minimize this type of residue, we recommend using a filter bag system. These systems recirculate the tank liquid, trapping soils, chips, and solid particles inside the bag. Filter bags should be replaced frequently to avoid reduced pump pressure and flow restrictions caused by the clogging. The step 3 is inspect the pipes and spray nozzles. After addressing the tanks, the next step is to inspect pipes, spray bar nozzles, and wash chamber. Over time, scale builds up in common areas exposed to the cleaning solution. Inside and outside the spray bars or the nozzles, the heaters, the filters, the pumps, and chamber surfaces. This accumulation hardens gaskets and seals, making them brittle, restricts flow inside tubes and spray bars, clog nozzles, compromising cleaning efficiency, insulates heaters, reducing heat transfer and increasing energy consumption, builds up anywhere the cleaning solution or the residue has contact with. Put simply, scale is the enemy of effective cleaning, and routine inspection is essential to prevent performance issues. We have a scale removal and descaling guidance. Regular removal of scale buildup is essential. Delaying it allows layer to thicken and harden, often requiring specialized tools for scrubbing and polishing. To easy removal, you can recirculate an appropriate descaling chemical using your washing equipment. Depending on buildup severity, this may require 2 to 4 hours at elevated temperatures recirculation. Even after chemical treatment, manual scrubbing of tanks, nozzles, and hoses may be necessary, followed by inspection for corrosion and oxidation. For expert assistance, contact your local KYZEN representative for a customized deep cleaning and descaling procedure tailored to your specific equipment. This example demonstrates how a deep cleaning process can significantly improve your washer condition. Spray bars were thoroughly cleaned and unclogged. Tanks were scrubbed, descaled, and pump filters and gaskets replaced. The chamber was fully descaled using an effective cleaning agent designed to remove heavy buildup. Maintenance checklist tips and tricks. Before leaving your equipment unattended during a shutdown, always turn off resistors or heaters. If left filled and in auto mode, heaters may continue operating, causing the liquid to evaporate and potentially burn exposed components, leading to costly damages of your equipment. One best practice is to fully empty the tanks, perform a deep cleanup, and leave the system dry. When restarting your plant, you'll ensure a smooth refill and optimal performance with fresh chemical. Why not leaving chemical in the tank? Chemical formulations can degrade or evaporate over time, even when heaters are off. Some components may separate into phases, affecting cleaning performance. This can lead to aggressive reactions with seals, gaskets, and other sensitive parts. So preserving your equipment means being proactive. This simple step goes a long way towards preventing wear and ensuring reliability. Now that we're talking about seals and gaskets, not all seals and gaskets are suitable for every chemical. Always verify material compatibility with chemical supplier. Some materials perform better with specific formulations. Your supplier should provide a material compatibility chart, helping you select the most appropriate option for a long-term durability and safety. While shutdowns are great time for deep cleaning and equipment checks, regularly scheduled maintenance is key to preventing malfunctions and quality issues. Consistent upkeep also helps reduce overall maintenance time in the long run. For systems prone to scale buildup, the scaling should be performed at least twice a year, especially if heavy accumulation has been confirmed. Final recommendations. Implement a computerized maintenance management system to efficiently track tasks, timelines, and equipment specific actions. Collaborate across departments, involving operations, maintenance, safety, and quality teams when building your maintenance checklist. Cross-functional inputs leads to faster issue resolutions and better communication. Reframe shutdowns as opportunities, not interruptions. They provide rare access to equipment and infrastructure, making them ideal moments for deep assessments, upgrades, and long-term improvements in safety, efficiency, and reliability. Finally, we have the frequently asked questions on this topic. The first one reads, why is it that scale could form inside our washer equipment? Well, scale formation is commonly caused by mineral buildup, often resulting from the use of hard water in your system. Hard water contains high levels of salts and minerals, which gradually deposit and create layers of scale over time. However, scale can also originate from the residues we are cleaning. Substances like oil, greases, flux, and other materials contain organic compounds that, when mixed with the cleaning agents, may produce soil residues. These residues can accumulate and lead to sludge or scale-like formations on the equipment surfaces. The second question reads, how can we prevent scale from forming? Is there something that can be done to avoid it in the first place? Well, that's a great question. If the scale is due to hard water, switching to a treated or softened water may help reduce or eliminate scale buildup. Some companies opt for the ionized water produced by filtering through a mixed resin bed and activated carbon, which results in ultra pure water suitable for sensitive processes. However, this option adds to operating costs, as filters needs periodic replacement. Another alternative is reverse osmosis treated water, which also effectively removes organic contaminations. If the residues that we're cleaning is the one that is causing the buildup, then there's nothing we can do to prevent this. In such cases, we recommend scheduling deep cleanings more frequently to avoid thick residue layers that require extensive removal efforts. The final question reads, how often should we perform or schedule a deep cleaning process like the one described? Well, if the scale buildup has been confirmed and switching to purified water isn't feasible, a quarterly deep cleaning process is advised. In cases of light scaling, a less frequently scheduled could work. Once or twice a year may be sufficient. Ultimately, the cleaning frequency should be tailored to the specific conditions of your process and the severity of the buildup. This is all for today. I hope this was interesting and helpful for all our audience. I send them back to you, Will.
Thanks, Luis. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.